Hello, everybody, and welcome to Grey History. Have you ever wondered what French scientists, elephants, and a creature known as the Ohio animal have to do with proving extinction? Are you now wondering why one would even need to prove extinction in the first place? Well, you're in luck, because that's what we're about to unpack. You see, episode 35, Science During the Revolutionary Era, is a bonus episode for all Patreon supporters of the show. The topic was voted on by all community members, and it's actually turned out to be 2 bonus episodes. Part 1 focuses on chemistry, and it explores the early work of Revolutionary-era chemists as ancient theories were replaced by the foundations of modern chemistry. This includes the experiments and fierce debates which were seeking to understand the process of combustion and the composition of both water and air. Part 2 delves into the life sciences of biology and paleontology, examining the early debates and ideas surrounding both extinction and evolution. Now, both parts go for just under an hour each, and both are now available for all Patreon supporters of the show. If you're not a Patreon supporter of the show, don't worry, because I've attached a 12-minute snippet from Part 2 on life sciences. In this snippet, we'll explore the initial debates over whether or not extinction was a real possibility, as well as the role that a French naturalist played in proving extinction using the bones of elephants and fossils from Europe and the Americas. Of course, if you're enjoying Grey History, if you'd like to listen to more Grey History, remember that the best way to help the show is to support the podcast on Patreon. For a small donation each future episode, you can gain access to a range of exclusive bonus content, including full-length bonus episodes and all the episode extras accompanying the main show. There are links in the show notes and on the website, or just Google Grey History Patreon. Anyway, that's enough from me. So let's get into this snippet of episode 35, Science During the Revolutionary Era. Welcome to Grey History. Episode 35, Science in the Revolutionary Era. Part 2. As early as the 16th century, the famous scientist Leonardo da Vinci had theorized that fossils were the remains of creatures. During Da Vinci's era, fossils were thought to be the work of forces within the earth, and not the entombed corpses of living creatures. This idea had been promoted by the ancient Greeks, and it still had considerable sway well into the 17th century. The English scientist Robert Hooke was critical to changing the way the scientific community thought about fossils. Born in 1635, Hooke invented a new form of microscope which allowed him to analyze fossils. Using this microscope, he noticed considerable similarities between fossilized plants and living plants, as well as fossilized shells and shells belonging to creatures of his own time. Hooke concluded that these similarities between fossils and modern organisms was due to the fact that fossils were organisms. Far from being the intriguing output of some inexplicable forces within the earth, fossils were the preserved remains of creatures. Hooke then went further. Noting that he could not locate living equivalents to many of the fossils which he analysed, Hooke began to promote the idea that some animals no longer existed. Thus, 200 years before Darwin's theory on evolution, prominent scientists were concluding that extinction was a real beast. However, this conclusion, that creatures which once lived no more, was highly contentious, even by the time of the French Revolution more than 100 years later. The primary reason for the topic's controversy was due to its religious implications. For context, you have to remember that at this point in time, the social composition of society was vastly different to that of today. A century before Darwin's theory on evolution, the overwhelming majority of people held that God had created all natural life, and importantly, that all life was part of a divine plan. This idea that all life owed its origins to being part of the Creator's divine plan was contradictory to the ideas of extinction. If God had created all forms of life, why would he then let that life die? It seemed irrational that he would create it merely to let it perish. This frame of thinking was tied to a popular idea of the time that all life formed what was called a great chain of being, a hierarchy which linked all matter of life. Unsurprisingly, God was at the top, and then followed by angels, then humans, then animals, then plants, then minerals. Again, if all species were linked in this great chain, why would God let some of them die? The proposal of extinction seemed irrational. It seemed contradictory to the very foundations of how the world was created. As the English poet Alexander Pope wrote in 1733, "All are but parts of one stupendous whole, whose body nature is, and God the soul." It wasn't just poets who doubted the existence of extinction. As the American president Thomas Jefferson put it, "Such is the economy of nature, that no instance can be produced of her having permitted any one race of her animals to become extinct, of her having formed any link in her great work so weak as to be broken." So, if extinction didn't occur, what about these fossils? What about the life they held within? Life which had seemingly vanished from the face of the earth? Well, one simple explanation was that the creatures lived elsewhere. Dive deep into the oceans, venture far into the jungles, travel across the unexplored wilderness, and there one would find these creatures. Simply because they didn't exist in Europe didn't mean that they didn't exist at all. It's here that we can reintroduce our French naturalist Georges Cuvier. In 1795, Cuvier was appointed assistant to the chair of comparative anatomy at the Jardin des Plantes, which I've well and truly butchered, but it can be translated to the Garden of Plants, and you can think of that as being part of the Museum of Natural History. As the assistant to the chair of comparative anatomy, Cuvier continued to develop his skills in the field, skills which would eventually lead him to being regarded by some as the founder of modern comparative anatomy. As mentioned before, comparative anatomy involves comparing the structures and body parts of various animals to gain a better understanding of how creatures lived. This might include studying jawbones to understand their diet, or studying their limbs to understand how they travelled. In the modern context, comparative anatomy is also used from an evolutionary point of view, understanding common ancestry and adaptive changes to an animal's structure. However, considering we're still debating extinction at this point in time, you can imagine the debates around evolution in the late 18th century. And indeed, we'll get into those debates in a little bit. So, Comparative anatomy was mainly concerned with comparing the forms of different species to understand how those animals lived. In 1796, Cuvier read his first major paper, and it regarded an animal that had captured imaginations for centuries. It involved elephants. The title of this groundbreaking lecture, which was subsequently published, was to the point: Papers on Living and Fossil Elephant Species. By carefully studying the jawbones of African and Asian elephants, Cuvier was able to definitively prove that the two types of elephants were different species. African elephants had teeth with ridges the shape of diamonds, while Asian elephants had molars with wavy ridges that reminded him of ribbons. These differences, proclaimed Cuvier, were testament to the fact that the elephant from Ceylon differs more from that of Africa than the horse from the ass or the goat from the sheep. Now, you may be wondering what this discovery has to do with extinction, because both Asian and African elephants are still alive today. Well, Cuvier was soon able to get his hands on bones belonging to an elephant-like creature which had been discovered in the Ohio Valley in the modern-day United States. Originally called the Ohio animal, it was Cuvier who coined the term mastodon, because he observed nipple-like structures on the creature's molars. Mastodon is derived from ancient Greek, meaning breast tooth. What I would pay to show Aristotle a photo of a mastodon and inform him of the future's decision to call it breast tooth. Alas, I digress. Cuvier was also able to get his hands on the bones of an elephant-like creature from Europe, what we would call a mammoth today. Using comparative anatomy, Cuvier was able to prove that not only were African and Asian elephants different, but that neither species were the specimens found in America or in Europe. The bones of the mastodon and mammoth were different creatures, and they were not Asian or African elephants. Driving his point home, Cuvier made the differences understandable to his audience when he stated that the animals differed at least as much as a dog differs from a jackal. With these differences now addressed, it's here that the scientist addressed the elephant in the room, or perhaps more accurately, the lack of an elephant in the room. Cuvier argued that there was simply no way these creatures still existed without humanity's knowledge. They were simply too big to go unnoticed. Therefore, these creatures had to be considered extinct. Some contemporaries doubted this, arguing that the world was a big place. With a great deal of territory still to be explored, it was possible that these creatures lived in undiscovered lands. But for Cuvier, and for an increasing number of scientists, it was this discovery, the discovery of distinct elephant-like species, which proved the existence of extinction. For the next few decades, Cuvier would continue his work in comparative anatomy to identify a huge collection of large animals which no longer existed. These included giant sloths, Irish elk, and variants of bears and hippopotamuses. But having proven that extinction existed, the question now turned to how. How did these creatures become extinct? Cuvier had an interesting explanation. I hope you enjoyed that little snippet of episode 35, Science During the Revolutionary Era. This episode, which is really 2 episodes, is available exclusively to all Patreon supporters of the show. If you're enjoying Grey History, if you'd like more Grey History, if you agree that history isn't black and white and should be retold in a way that embraces the ambiguities and nuances of the past, then please do support the show on Patreon. Your contribution will go a long way to helping me produce more regularly and more frequently, and there's now 4 bonus episodes for Patreon supporters of the show and hours worth of episode extras as well. In fact, there was 30 minutes of bonus content for episode 34 alone. So please, if you're enjoying Grey History, tell your friends, tell your family, and if you can, support the show on Patreon. Episode 35 and other bonus episodes are waiting for you right now. As always, thank you for listening, stay safe, and have a great day.